So I think last class we finished topic 1, but some of you have told me that I little bit too fast. So I just quickly review what we have done and try to see. I also go over the picture about the CV and EV again. I mean the graph I skipped last time, so probably it will be better. So just to remind you again what actually we are doing. Okay, there are several things we have done in the topic 1. First is to different from intermediate class where we just consider utility. We go back one step backward, what is preference, and try to link those. And then we start from very basic concept of preference as a rational idea. You have a transitivity and you have completeness, right? Completeness where means you can always compare 2 bundles. You can always say one is better than the other, or both, right? No worse than. Or you have transitivity where you never have a cycle, right? When A better than B, B better than C, and A must be better than C. So there's no cycle exists, and there's a rational preference. And this is simple, but it's not enough to derive utility, right? So there are 2 assumptions we need to assume to derive utility. One is monotonicity, the other is continuity. Okay, when you have a monotone continuous preference, then we will arrive utility function. So assume monotone, right? Monotone more the better. And continuity means that if the strict preference, okay, and in the neighborhood also continue to hold, right? When X better than Y, nearby of X is also better than nearby Y. So that is continuity, what it means. And with monotone and continuous preference, you have utility. Okay, so that is the proof we have done in this mention, right? We just mentioned you just go to the diagonal and always find the number there, and that would be our utility function. And after that, we are need to put more structure on the utility function in order to have solution for utility maximization problem. So what we need is what we call quasi-concave concavity. So just if we have when we have a quasi-concave utility, okay, which is what we equivalent to what we said called convex preference, okay, which means that mixing bundle will not make you worse off. In that case, then when we have quasi-concave utility or convex preference, in that case we ensure that ourselves, when we solve this utility maximization problem, you always have solution. Okay, and just to remind you again that when we solve this problem, we assume the price is exogenous, your income is exogenous, and so everything exogenous, so basically choose a bundle. Okay, and of course this can be relaxed, right? Because you can imagine that Y, although it's exogenous, but you can imagine that you are choosing some leisure, right? And on lack of leisure, then give you some money. But anyway, that would be something. When you talk about labor economics, that would be something covered, but we are not doing that here. And one important thing we learned last class as well is we solve this maximizing problem, and just what is the result for this problem, right? We know that when we have we just said the quasi-concave, when you have quasi-concave preferences, you need, right? So turn out to be this can be the Wawa's law saying that you would use all your budget when you have monotone preference, because you never left something out on the table because you always want to spend some money, right? Because the money left, there's no utility of money. Okay, in this model, there's an assumption is having money in the pocket is not going to make you feel better off, right? Because your utility based on the set of bundle, not the money left on the table. So that's why you would always consume everything. Okay. And what it said is the optimal condition for this utility maximization problem is where your marginality or substitution is same as the price ratio. Okay, actually we will see that today. It's also optimal when you talk about the firm. Okay, because firm is combining input to produce output. It must be the case that the price ratio of the input should be same as the margin rate of technical substitution between the for the firm when they produce. But I will be more clear later. This we'll see again. Okay, again the idea, the intuition is the same. Is just like this is the external exchange rate, right? You can swap between good I and good J. That's the rate you can change, right? Suppose you give up 1 unit of good I, that give you income, extra income of PI, right? And how many units you can buy is divided by PJ. So this is how you exchange rate, right, for I and J. And this is internally for you, how much to keep you as happy as possible if you give up I for J. Right? So that is make sure that this is the same when you are consuming positive amount for both good, right? When you have interior solution, your corner solution, it must be the marginal utility of that good is less than the utility that you need to spend money on it, right? So this is why price times the marginal utility of wealth. So that is the FOC, right? And just to recall that the condition for this, right, the internal rate and external exchange rate, we have the same condition when we have the minimization problem, right? The expenditure minimization problem, okay, is also have the same result, okay, because that's a dual, right? So the same thing. When you maximize utilities subject to budget constraint, just to remind you, in this particular case, right, this is x1, this is x2, right? We have two things we need to work on, right? We have a bunch of possible indifference curve, right? And we also can have possible bunch of budget line, right? And in the utility maximization problem, we fix the budget line and move the indifference curve. And the expenditure minimization problem is just reversely, we fix the utility function and move the different budget line, right? Because we solve for any arbitrary budget line or arbitrary utility function, right? Value, then they are the same thing. Okay. So this is the UMP, and this is the result. And because of uniqueness, then we can write the outcome of the utility maximization problem as the Marshallian demand, right? And if you put the Marshallian demand back into the utility function, then you get the indirect utility function. Okay. And they're the same thing, but just look at different perspective. And what are the property you learn from all this is one important thing you learn from, or probably the only thing you know from the Marshallian demand is just homogeneous of degree 1, sorry, homogeneous of degree 0, so, which said if you double the income, double the price, everything remains the same. So that is a direct consequence of the FOC, right? Because only the price ratio is important, right? And there's a relative income, that is the real income, that is the main thing, okay? And there's nothing we can know more than that because demand is most complicated. So if your income increase or decrease can change your consumption, and same as price, okay? So that means that our goal of having this is not very successful, right? The goal of this is like for any arbitrary good, we want a downward sloping demand, right? This is our goal at the beginning, right? That is the main goal of studying all this is try to derive that, right? But even though we are unable to ensure ourselves we have downward sloping demand, we learn at the end we have a what we call the Slutsky's equation that says if the income effect is not very strong, we still have downward sloping demand. Okay, so what does that mean? It means that when we focus on small industry, this assumption is correct. There's no problem. That would be a problem. We're talking about a big economy. Okay. When you talk about a macroeconomics, that would be fail, right? So you can imagine we talk about inflation or deflation, right? Recently talk about stagflation, right? It's like the price goes up, but the economy is not doing very well. Things, and also all these things, right? This some kind of violation of this rule. Anyway, that is not we're not talking about macro, but that means that, I mean, things that macro and micro sometimes break down. This kind of thing can explain one part of the reason. But anyway, so so just look at this example. This example is something you generalize this example, that would be assignment, right? Yeah, I have Cobb-Douglas function, but the exponent is 1/2. But in assignment, I allow arbitrary numbers, so you have to figure out what are those numbers to guarantee that you satisfy the requirement for monotonicity, right, caustic concavity, so on and so forth. Okay, you see it. So I'm not going to go to detail, but just want to say that this is very important function that you will see a lot of papers because it's very convenient. Just to, because why convenient is it's easy to see when you add one more good to this model. This utility function is also still well defined and also has a very nice property, and that is convenient compared to others. Other utility function you want to add on. Okay. But anyway, we're not going to talk about this, but you look at literature, there's a very good support for this. So that's why when you really want to work on a model that require more general than all this, then you can work on this one. But of course, I always recommend you start with Cobb-Douglas because I think it's the one of the good general one you can start with and do things. And for the indirect function, I think that is something nothing very surprising. Is the property will be decreasing in income and not increasing in price, and change in price and income will not affect, right? Almost decrease. And also this little bit not so easy to see is the technical condition, what we call the Royal identity. And this comes directly from what we call the M.Phil theorem. You just differentiate this and then just do the division, gets you this one. And so that would be the outcome. So probably you want to know why this one is important, because the importance comes from the fact that it's easier to estimate the indirect utility function. And once you estimate that, you can derive the demand function. So that is the empirically, that's why this is important thing, because you can observe a price and income easily rather than observe utility, utility, right? So if we're able to come up with a good, you assume some functional form of V, right? And you can estimate this V function, then you can actually derive the demand function. So that is some way to easier to handle the problem. So that's how to derive the indirect demand function. And the next one is the expenditure minimization problem. Okay, so just as I said, you just, instead of moving the utility function, but you are moving the project line. Okay, and again, you will take this utility as given because you solve it arbitrarily. Okay, and it looks very unnatural because this is something not really you cannot observe this, right? You cannot say what is my minimum utility, try to solve it. Okay, so it's more like the arbitrary thing, right? We cannot really empirical observe this guy. Okay, but there's some benefit to work on this idea. Okay. The reason is being that later you will see why this is better, because expenditure is something you can measure directly, so it's better than utility. So now so what do we have is this must be binding, okay, when you have a monotone preference and when price are positive. Okay, there is something very minimal requirement. Okay, and as I said before, the optimal condition you get is the internal exchange rate same as the outside exchange rate. So this is the same when you have the utility maximization problem. Okay, and this is same as the budget line is holding. So that's nothing new. It's just like depending on what is your fixed level, then this is what you get. Okay, because you solve a class of problem, right? So instead of one problem, you solve a many problems depending on what input is it. But always this is whole, right? So just remind you what this is. It is the optimal solution is they tangent to each other, right? So that is something probably you should have known, right? So we have fixed and demand, and I didn't put the existence or the uniqueness. The unit same as the utility maximization problem when you have a strict quasi-concave preference. Okay, you will have unique solution because the same thing, right? Because in that one you just move this guy, right? Then when you have unique solution for the utility maximization problem, you have unique solution for the EMP. Okay, but I'm not putting that there, but maybe I should have. But I think it's clear that they're the same problem. So when you need for one, you need for the other, right? So that's something should not be any difficulties. And here the first one is not very surprising. I think a typo. I should have a lambda. No, sorry. Oh, sorry. That's right. Sorry, that's right. Yeah, that's right. Yes, I think this is not 1. This will be 0. This will be 0. So it means that when you double the price, okay, by achieving the same utility, you should consume the same. So doubling the price should not change your consumption, right? Will be the same point here because the slope doesn't change. Change the price, this is the same graph, right? So yeah, the math is correct. I think this is I should not say 1. Okay. This is the main thing we want to derive here. Why we want to do the expenditure minimization problem turn out to be this is the main conclusion we want to derive is when we talk about the Hicksian demand is actually downward sloping. So basically just like we want to derive this, although we don't, we have another thing that is also downward sloping. Okay, can be like this, can be like this. Okay, and whether you have the blue one or the red one depend whether what's the income effect. Okay, depend whether the good you're considering is a normal good or inferior good. Okay, so it must be downward sloping demand. Okay, if this is a Marshallian demand, it can be either here or either here. Okay, later we'll see which one is which. Okay, but I just keep it here in your mind that we're able to derive the Hicksian demand. Okay, it's a downward sloping. Okay, so that is the one thing. And And if you put the Hessian demand back into the expenditure function, what you get is the so back into the expenditure, so you get the expenditure function. Okay, so here this run is right, because if you double your prices, you have to double your expenditure, because you're consuming the same bundle, but the price double, so that's why it's 1. Okay, so that is correct. Just this is correct. And it's non-decreasing in price, because price goes up, you should consume more. And this is the sharpest number. Okay, and last time some of you said this is not very clear. Why is concave? So I just add a graph in the new slide how to explain that. So assume this money, this is consumption here, this is a price. Okay, and I try to argue that this is concave in price. The reason is being they look at certain price level. The optimal point is here. Okay, and by changing the price, keeping the same bundle, this is what is the money you are going to spend. Right? You are consuming, say, at this utility, you're consuming, say, 1 apple. Right? 1 apple may cost $1. Right? If the price goes down, okay, you can still consume the same. You just reduce your consumption, right, linearly, right? If you don't change your bundle. Okay. The red line is being that the price change, you still consume the same bundle. Okay. That's linear, right? Because that is P times X. You're still using this price, the bundle you give, this utility, you consume the same along this line. You got more expensive, then you consume more, right? But the fact that if you do it optimally, right, you're able to do some substitution, you're able probably to reduce, right? So that's why your optimal point will be low to that. Okay, so that's why it's a concave shape, because you can do it for every single point. Everything next to it is always less than, so that's why it's concave. Is that clear? Is that clear why it's concave? Let me repeat once more again. Okay, so this is the money, this is the price. Okay, at certain price, okay, I would have an optimal bundle, which is given by this one. Okay, and at this optimal bundle, I'm keeping this. Okay, while changing the price. Okay, if I just keep the same bundle but I change the price, then my expenditure will be changed linearly, right? Because I'm not changing my consumption package. If only P1 changes, then just change linearly, right? Because suppose I always say buy 3 units of good 1, right? 4 units of good 2, 5 units of good 3, then P2 is not changing, P3 is not changing, right? It's fixed, right? And I have P1. If P1 go up and go down, that the expenditure just change linearly, right? This is not changing. This price not change, right? That's why that's linear. This is a line where you keep the same optimal bundle at the price, okay? But you just don't change anything, okay? That is the thing that you do optimally, right? And you do something better, right? You just maybe, if the price goes down, maybe you should spend more on 2 and 3 because they may be substitute, right? They can be, right? May not or may, but at least it's possible can go down. So it cannot go up, so it can be like this shape. So it must be this shape. Okay? At least it's like this shape. It need not be look like this, the blue one, but it must be below. And every single point you have the same feature, right? So that is the idea. Okay, and also you can see when I draw this graph, the tangent point. Okay, it's not surprising given we have the property, the Shepherd's lemma, right? Which is not surprising, right? When differentiate, change the P is same as the consumption. It's not surprising because you change one price a little bit, right? How much is changed your expenditure, right? It just little bit increased, then the substitution effect is very small. So we just increase the same as the price. Okay, so just like I'm consuming 4 units of 2 and 5 units of 3 and 3 of 1, right? If the price gets go up by a little $1, not $1, 10 cents, right? I'm not going to have very little change. I probably don't change my consumption, right? So how much my expenditure change is just based on how much I have consumed, right? I increase this by very little amount, probably no change on this one. So my expenditure only changed by this guy. Is that clear? So just is it clear? So basically, just like if I change to P1 star, okay, and this P2 the same, P3 the same, okay, it's very likely that I consume the same amount, right? And probably I also doesn't change my consumption at all, right? Little bit, maybe just a little bit, right? So I just look at the E and the E star, then just based on this, right? Right, you just change in E, right? Will be just 3 times change in the price, okay? And just that's why this will be just 3, which is just the XI, right? So I hope, but of course this comes from the M.Phil theorem. Nothing deep here. Just finally, we look at this graph is what we have substitution effect and income effect. And of course, you can imagine this also apply later today, talk about the firm. But for firm, it's much simple because they would here it's possible that the substitution effect and income effect can be opposite. But for firm later, you will see they are on the same direction. Okay. So substitution effect is the fact that what happens if you keep the same utility but changing the price? That's how the substitution effect. And if you move from instead of changing the price ratio, you just compensate back the income, then you get this one. Okay, and we prove it. I'm not going to talk about that anymore for the math, but just very quickly to explain why we have this, right? Is why when we have normal good, then the Hicksian demand is steeper. The reason it being that the difference between these two is the income effect, right? Because when you look at the Slugky's equation, this is exactly the Hicksian demand, right? This is a Slugky is the Hicksian demand minus certain thing, right? Or plus the income effect, okay? And it turns out, right, when the price of good one goes down, okay, you have income effect, right? The income effect is being positive. The reason is being that the price is less expensive. Even though you keep the same bundle, right, you have extra money left, right? Because good one is cheaper, right? So even you consume everything the same, you have extra dollar left. The extra dollar left, how you go into dispute, right? And the fact is you would, in terms of normal good, you will spend more on good one. Okay. In that case, the Marshallian demand will be more than the Hicksian. Okay. Same for the price goes up, right? For the price goes up, you can't consume the same bundle, right? There will be money deficit, right? Then in that case, you have to cut out. Yeah, so question. You have cut out consumption of good one. So that's why the Marshallian demand will be less than that. Is that clear? So when you have inferior good, it will be opposite case, right? Because when the price goes down, right? If inferior, you have more income, you would consume less. You consume less. So that's why for every point, you just go to the left-hand side. Okay. Same the other way around. Is that okay? I mean, understanding this is, I cannot say important, but it's you will know why they're different. Okay. And as I said, I mean, we're focused on one market. the income effect tend to be not there. Okay, so that's not a concern. Okay, as I said, when we talk about macroeconomics, then it can be an issue. Okay, so when the price goes up and go down, things can be very different, right? When you're inflation or deflation, when you have a oil price goes up, and things can be different. Okay, because there's an income effect there. So that's why macro is a very different subject than the microeconomics, right? Because when income effect goes in, then things can be screwed up a lot, right? Can be very different. That's welfare. I think I should give more thought for this one. Okay. So the definition of this is not that complicated. It's rather look at the graph will be much more easier, because I think last time I have two graphs put together that makes probably your mind a little bit bows off. So this originally this is the demand and this is the optimal bundle. Okay, and you consider a new price changes. Okay, now is the good one is cheaper, so we end up in this bundle. Okay, this is the XP1Y. Okay, and this is a two bundle, and actually we know if we follow the Slutsky equation, right, you should just change the price ratio, you end up with the red point, right? It is the point where you keep the same utility, right? And you jump here, there's the income effect. This is substitution effect, right? And now you look at this, right? If the good one, the good two have price of 1, okay? In that case, how many units you consume, right? When you consume nothing, okay, is exactly Y, okay? Because that is P2 of X2 is actually Y, because price of 2 is 1, okay? And that is expenditure, right? When you, this is P0, V0, this is the expenditure, same as this point, okay? And this point, you go back, will be that under the new price, but all utility, okay? And this is the income effect, right? Look at this one, okay? That is what we call the compensated variation, okay? So basically, you can think of the fact that when you talk about the Slutsky equation, which probably you know very well, that's exactly the compensating variation, right? Just you consider the substitution effect first, and then you look at the income effect, okay? That income effect we used to know is called compensating variation. What is it doing is how much, okay? You need to compensate this guy, okay? Looking at the new price ratio. Looking at the new price, okay? Look at new price, how much you need to compensate or take away from him so that he is as happy as the new and the old. Okay, in this case, you take away his money, right? Because price goes down, okay? And it's normal good, so it's just like this is money you take away from him, okay? He is indifferent between I put a change, okay, or I'm not, right? Because the utility is the same, okay? Is that clear what the CV is? Okay, this is following the standard Slutsky equation. Okay, this is nothing new, but the income effect we have to set is just the CV. Okay, so now you can imagine that we don't have to do it in this way, okay, because we are looking at the perspective of the price is after change, right? Can we talk about before change? Okay, that is the idea of CV. Okay, so how do we do about that? We just what we're going to do is, instead of looking the substitution in this way, we figure out it in the reverse direction. Okay, not start from the beginning, but start from the end. Okay, you just imagine that you're reversing the price change somehow, right? It's the income effect in opposite direction. Okay, okay, so before is the price from here to here. Okay, So we just like return to the future. Okay, you start from the end. Okay, start from the end. Okay, look at the keeping this utility. This is the substitution effect, and go back there as income effect. Okay, so if you think in this way, that is also the same as the income effect, but you just reverse the beginning and end. Okay, okay. So that is the income effect, right? That's why we call it is equivalent variation. It's because if I give you this money, right, and you don't really care about the change, right? I think the change is the same. You will get the same utility at the end, right? At the end point. Okay, you just focus on the end point. This utility, I give you this, then you'll be the same. Is that clear? So just to remind you what's going on can be very confusing. Okay, the CV is just the standard way we have been thinking when we talk about substitution effect and income effect, right? That is very standard way to think, right? We used to think in this way, right? But now if we just swap, why we start from here up to here, right? Can we do the opposite way? Right? We do it opposite way because there's no hard and fast rule to say why we have to start from that direction. We go back, right? We start from here and go back, and that's called EV. Okay. So just to remind you the terminology, right? It's just like compensate, right? Just like that's why you say starting at the new price. Okay. How much I need to compensate, and equivalent is like there's no changes. That's equivalent to the changes. So that's how the term comes in. Okay. So I hope that is clear what's going on there. But if you look at the Rennie textbook, I think they just focus on CV because CV is very naturally thing that you would be doing when you learn this Lucky's equation, right? Because you just keep the utility same as before, right? It's just how we compare. That's to consider substitution effect in this way. And the EV is also mentioned because we want to show one thing is looking at these two, right? Turn out that these two number, right? We do the integration because the expenditure function can be written as the integration, right? I'm not going into detail, but that is the proof is there. But what I want to say is when you don't have income effect, right? This is same as the standard looking at the consumer surplus, okay? And if it's normal good, you have this, and inferior good, you have that. So it's always in between. So let me spend the some time to walk with you for this one, because I think that would be good to understand what's going on here. Okay. So originally, okay, you start at this price. This is your bundle. Okay, and this is the point. And we'll explain that if it is normal good, it will be like this, the blue one. The reason is being that it's normal good, the price goes down, you have more income, right? It's normal good, you spend more. Okay, you jump from Hessian to Marshallian, it just go down, go more in this way. Yeah, other way around, you go that way, right? Is that clear for this one? Okay. Now, price changes means I consider the price goes down, say, okay, from P10 to P11, you go down here. So if you follow the Marshallian demand, you go to here, right? And at this point, the Hessian demand is like this. Okay, the reason is being the same as the blue one. Okay, is that clear? So the blue one is the Hessian demand in the old price, the red one is in the new price. Okay, so then why this is the red one is the EV, the blue one is CV. Just go back to the definition we have. CV is looking at the old utility, EV look at the new utility. Okay, So EV, look at the new utility, we just integrate. The CV is look at the old utility. Is that clear? So in that case, you can see, okay, EV is here, okay, CV is here, and CS is in between, right? CS is along this. I didn't have it here, but just like this guy, right? Is that clear why EV is between CV and CS, right? CS is in the middle. I didn't draw it, but CS is this guy, right? So this is CV, this is EV. Okay. And this is the opposite case when we have price change in the opposite, the price increase. Okay. Now is instead of the price go down, sorry, now go down, now we go up. This original point, this end point. Okay, this line like this is as usual, right? And EV is looking at the new utility, so it's smaller. Okay, the CV is looking at the old utility. Okay, so this is bigger, and in between is the CS. Okay, so that's why we have this. Okay, and you can draw it by yourself. I have normal good here. If I have inferior good, okay, where the lines like this, we still have the same result. Okay, CV is always CV and EV always in between. Okay, but you will see the thing swap. Okay, but I guess I just the exact thing is not very important, but trying to convince you why in economics or IO or regulation, we focus on consumption surplus. Okay, consumption surplus by itself has no meaning in preference. Okay, but it's a good approximation because we don't know which direction is it, right? Unless we know whether normal good or what. But CS will be always in between the two. Okay, it's hard to know the income effect, right? So that's why we focus on small industry or one industry by itself, right? It's small compared to the whole economy. The income effect is, we can assume zero. So that's why this is the assumption that how, say, US regulator, right? They would do that. Okay, actually they explicitly say when the market is small, that is appropriate, right? When big, then it's something you have to worry about the income effect, right? If things that happen. But I hope that's clear what we're doing in the here, right? It's not something this all the proof, the graph for this one is not important. Just to say, okay, all we do for the consumer surplus has some foundation from the preference, because CS has no foundation from preference. Okay, but the EV and the CV has meaning, right? What do they mean? It's meaning how much you need to compensate him for the changes. Okay, taking either the new price or price, and this is the money measurable metrics, right? For the Marshallian, you integrate that, it's not very clear what do you mean by consumer surplus. Okay, but here there's a clear meaning. It's how much you need to compensate that guy. Okay, it depends on the initial price or the end price. Okay, it's the reference point, and this is turned out to be the thing we care, right? How much I need to pay to make them happy, right? It's like whether there's a good or bad, right? And there's a policy evaluation. A lot of people they would do that, right? I hope that's clear. Is that okay? Then let's, if no question, then that's a break, and we will start the producer. So don't worry, the time is spent on consumer will not be waste, because you will see everything is very similar with consumer, but actually even simpler. Okay, so you may ask, why don't we have the producer first? But that is the classical way people start. So I don't want to change the order, but this is easier. Okay, so let's have a break. We'll come back at 10:30. Which one?
This one how to draw is using LaTeX.
Oh, they have LaTeX here.
Yes. Or more specifically, which package you
Text.
yes, but
I do text, but you can do PS strict, but I do text.
I mean which package?
Text TIKZ. TIKZ. Oh, I mean, if you try to look at but maybe look at my chat. I think I have my channel. Yeah, that's how I do it.
So now, suppose they want to draw this cost function.
Okay. For homework, you can just handwrite or write on your iPad and just get a picture. Okay. I mean, don't submit the hard copy. There's a minor typo at the for the ungraded part. Someone told me there's no delta. Actually, there's alpha I. So because there's no delta in the statement, so just does it depend on alpha I? So just this is the typo I made. And yeah. And for the assignment, you just no need to think it's a math assignment. So I'm not asking you to do it very strict. So we just do the normal way will be fine. Just like asking you unit solution or what are the condition, then you just think something that is reasonable, restriction will be fine. No need to prove the smallest possible thing. Okay? As long as you think normally, then you will just will be okay. Okay, just no need to be too worried because it's not math class, so I'm not expecting you to do something very mathy. Okay, as long as you do something reasonable thing, then it should be fine. Okay, I mean by reasonable, I think you are big enough to know what's reasonable. Okay, although very weak, but I think it's very should be clear enough. Okay, I think I should start because we're a little bit behind the schedule, but I hope that, I mean, by reviewing and keep going, I mean, I hope that would be things become more clear. Because at the end of the day, I guess you wouldn't remember anything, most of things. then I hope you still remember what we did is just to derive the demand function for topic 1, and then we start some idea of utility and preference, and that's all. I mean, most likely you don't remember anything. I mean, for some of my research, I just rely on linear demand. Right? I wrote several papers just based on linear demand. Okay, so so it's not something like you would remember most of things, but I hope that gives you some idea how things work. Hope that would be good. The same for this. I'm pretty sure after this one you won't remember a lot of stuff, but I hope that the way we solve the problem will be useful. Definitely you will forget all the details unless you pick up the book again. But I hope what we want to do is to complete this demand and supply picture, right? So what we want is with downward sloping demand from the topic 1, here we want to get is an upward sloping supply curve. Okay, or see how the firm make the supply decision. Okay, and that is the goal. And this is holding in general, but probably you would know when we have game theory in the second half of the class, and you will see while the demand function is okay to continue to assume that, the supply function is a little bit not a good idea. And even that, for monopoly, then it's not, you don't have this thing, right? Because monopoly decide price and quantity at the same time. Because for monopoly, he's facing the downward sloping demand curve. He can pick whatever point he wants. Okay, there's no particular supply curve, because supply curve means at this price, how much will be the market supply, right? But the monopolist actually facing the demand by himself, so he just pick whatever he like, right? So that is not there. But when we talk about the market's competitive, then this thing holds, right? So this for producer, that's why I said we don't start with this, because this is not very general in that sense. But when the firm is small compared to the market, everything would work nicely. At least the idea we talk about, the cost minimization problem, as later we will see, is going to be good. But the profit maximization problem will be different. The cost minimization problem will hold actually for any scenario, because it's just like how the firm can combine his input, right, to produce certain output. That is holding for any market structure, right? But the profit maximization problem will be different, because of the fact that whether the market price change according to how much you produce can be depend on the market structure, right? Because how much you produce can affect how other people will produce, right? In that case, the price is, you're not facing the demand function, you're facing is a little bit different. Okay, so but nevertheless, you will see different from, as I just said, different from consumer, right? There is a close connection between the maximization and minimization, but the firm that will be less connected. So that's why studying two problem is important, right? Because as I said, cost minimization would hold for any scenario, but the profit maximization problem, if you take the price as given, is not appropriate. Okay. Okay, but anyway, you will see at this. I don't overview too much. So we'll introduce all this, and we'll start with our technology. Okay, that is same as we start with preference. Okay, we start with something primitive. Is how firm can combine input to produce output. Okay, and there will be what we call the cost minimization problem and problem maximization problem. So you can see we have to talk about cost minimization first, because that's more general. Okay, and then we have make some assumption about what the firm behave, where the firm will facing a competitive price environment. Take the price as exogenous, then we have this profit maximization problem. Okay, and then we talk about consumers produce surplus, but that this time will be much easier, because basically this is the profit. Okay, but later you will see. Okay, so there are many things, but don't worry, most of them just definition. Okay. So we don't really I read it fast because that's definition. Doesn't worth too much attention to it. Okay, I think last time we talked about, we focus on looking at the profit maximization problem, because firm are profit maximizer, okay, and this assumption is okay when we talk about, we forget about what is internal mechanics the firm, just like the firm is a black box. We don't talk about promotion, we don't talk about human resources, we don't talk about the incentive problem within the firm. So that's ignored. And for those who study finance properly, they will think that's very important because that was what corporate finance or contract theory is about. Okay, so or people who study organizational economics, they would or organizational structure, they would think this is, but actually they're what they're doing, right? Because the organizational economics or study of organization is basically actually go into detail of how firm would work. But we just, for our purpose, we just ignore. Okay. And what's production? We can define in the following way, just like transforming input to output. Okay. And consumer, just if you think in this way, consumer just change the output or commodity into utility. Okay, so that is how we define production. So it's a function that, or correspondence that transform one to the other, okay, or multi-value function. So so we start with the consumption, about the consumption plan, consumption bundle, the same idea. We have the production plan. Okay, but this is a little bit more complicated than consumer. Okay, consumer, okay, you can assume once that consumption, you can usually represent, if you have a continuous preference, you can represent your happiness by one number, right? Which is your utility, right? You can use utility to represent preference, okay? And you reduce everything to one dimension, that's fine, okay? But that thing cannot be done for production, okay? Especially when you produce more than one good, right? You cannot reduce production of two types of car into a single composite index, right? So that make the things become very complicated. Okay, so what do I mean here is, right, is when I have consumer, okay, I can represent what is possible is in this graph, right? I just consider a point here will telling me how much good I consume for X1 and how much good I consume for X2. Okay, but for the firm, that is much more complicated, right? Because you can potentially think one input is coming from output from other process, right? In general, that is a very complicated idea. Okay, so how economists think about this idea is, you would now extend to the case a production plan, okay, is a number that extend more than positive number. You allow negative number, okay? Negative number means a negative input, okay? So just consider the world only have two things, good one and good two, okay? So now instead of just focusing on the positive region, you will think in this way. Okay? And I probably follow the notation I have here. I use Y because so that you don't confuse with X. I use Y1 and Y2. Okay, Y and Y2. Okay. So what is here is, okay. In this framework, okay. If only just two good, well, okay. Actually, you can't have this. You can't have this. Why? Because if you can have this pawn and this pawn, means that you are the God, you're creator. You create from nothing, you create something. Okay? What is possible is only these two regions. Okay? Suppose, what is this pawn mean? You are consuming this amount as an input. Maybe I use the blue color. Okay. For this pawn, what does it mean is this is take Y1 as input, okay, and you produce Y2. Okay, same as you're down here. I use a red color. Okay. You consume this. You consume this much, okay, and produce this much. Okay, negative Y means your input, and positive means output. Okay, in that case, because this is only possible region, this is not possible. Okay, I mean, of course, I don't know whether you can allow it happen, but in our physics world, I mean, at least we know the conservation of energy, conservation of matter. Probably you can't have this. Okay, they don't have free lunch. Okay, it's a closed system. I mean, that have to be either way around. Okay, so in that case, if we have a vector, okay, here good 1 and good 2 will be the input, and good 3 will be the output. Okay, you take 1 unit of good 1 and 2 units of good 2, then you can produce 3 units of good 3. Okay, and for our purpose, actually same as the textbook, the running textbook, we focus on single output technology. Okay, but potentially you can see I can allow have a any kind of dimensional output, right? Because multi-dimension thing, right? I just can draw 2 dimensions, but potentially can think about 3 dimension or 4 dimension or n dimension, right? And a process for one production can be the input can be coming from the output of the other production, right? So that's why usually we can't say what is negative, what is positive, right? Unless you know very well, say, good 1 is the crude oil, probably you cannot produce it unless you put it down the earth for million years, right? And so something is consumable, cannot be produced, but we don't put those things in there. We just allow every single element can be produced and made, and what can be made or what is not then is determined by the production plan. Okay. And that is what is feasible. Okay. And the set of the feasible plan is called Y. Okay. So if you, as I say, if you consider the case where you cannot produce thing from nothing, right? And Y cannot be here. Right? This cannot be Y. So the question, what is Y in this context? Okay. And in this context, okay, you should see something like this would happen. I don't know what the shape, but it will be, if this is the frontier, this will be the feasible set. Why? Because this is how much you consume, right? The maximum you can consume is this point. You cannot go further, right? So everything below is feasible. Okay. Same if you draw here, okay, you would face at this consumption here, you would see something, but I don't know, something like that. So this will be, this the red and the blue will be the feasible set. Okay. I mean, of course, usually there's one of them will be true, right? Because usually you think one of the input, one of the output, right? So, but I don't, I mean, without anything, I just allow this happen, right? So, but usually when you remember, when you learn the intermediate class, right? If this is a one input and one output, it's f of x, right? Something you will see something like this, exactly the frontier of here. Okay, just, but now I just swap to the other way around, right? If you take this input, this output, right? Just the blue one will be the thing you are talking about, right? So probably you would ask why we care about all this, but when you talk about a whole economy, then you have to think carefully, right? Because input and output is not something well defined. Only when we talk about particular production plan based on the technology, then you can talk about input output. Right? The whole economy, except some very raw material, you can say that's the input for everything, but otherwise it's very hard to say. Right? So that is the YIC. Okay. And usually exclude this too, right? If you allow this too, then you can just keep going. There's no economics. But if you allow this happen, then you just keep creating, right? So is that okay? So as I said, we just focus on the case that only single output, the same as the textbook that Randy they use. But you look at Mascola, Winston Green, they would allow arbitrary, okay? And the math would not be actually very complicated if you even allow multi-product, but since the book follow, I just do this, okay? And I guess for business school purpose, I think that is sufficient. Even if you have a multi-product firm, this still okay. I mean, it's not, there's no loss of generality focus on this one. Even multi-product firm, that still be fine, okay? Everything actually can extend to multi-product thing. So that's why I focus on that. And to make our life easier, okay, we just drop the notation, everything is Y. We will say output is just Y, okay, a non-negative output, okay? And input a positive number. So that's why we go back to this world, okay? The only difference between this and I think the intermediate is we allow this to be n-dimensional input, okay? So that is the only thing that extends from the intermediate class, okay? Of course, if you look at Mascola, Winston Green, they allow this to be m dimension, but we just make things easier, okay? So we have production function, okay? That is coming from the production set here. Okay? It just like this is from Rm plus to Rn. Sorry, Rm plus to R, okay? R plus, okay? And in the classical case, probably you would see is we assume one, if you're two, usually one is capital, one is labor. Okay, that is usually used in a lot of macro or trade or a lot of calculation like this. Okay, and nothing I want to say. Okay, so here that is the assumption I want to make is we assume the production function is continuous, slowly increasing. Okay, and a quasi-concave, okay, and you can produce nothing from nothing. Sorry, you can't produce something from nothing. So if you're nothing, then you're nothing. Okay, and I think continuous is kind of technical, just like you change some input, that output should be similar. So I think that is something not very surprising. Strictly increasing, I think that's also fine. You increase your input, you should increase the output. I don't think we need to. It's okay for most approximation, but I think the most thing I need to talk about is strictly quasi-concave. Why we have that? Okay, it's not entirely clear why this is better, but it simply means there are some complementarity in the input. It means that look at really quasi-concave, it's same as what we learned in the consumer, same thing. It just go back to here. Okay, quasi-concave means you're mixing them is better than the minimum of two. Okay, so we just replace U by F. Okay, take two production plan, right? Mixing them is better than the minimum of two. Okay, so what does that mean in here in production? There will be some complementarity. Okay, so that's why say capital and labor, right? There's some capital labor, and you combine, you just consider some mixture of that, then should be fine. So that's basically like this. I just erase this one, right? Say, if I have say labor and capital, right? And at this particular point, I may have some production level, right? And at some other point, okay, I also have some production level. Maybe I draw it here because that would be a little better, because otherwise by increasing, then of course better. Okay, so I have 1, I have 2 here. Okay, I don't know which one is better. Okay, but doesn't really matter what the strict quasi-concave set is. Okay, I pick something in the middle. Okay, this middle point is always better than the worst of the two. Okay? Worst of the extreme. Okay, that means that I combine some capital and labor. Okay, it's always better than the worst case. Okay, so it means that I mixing things cannot be worse off. So I have some capital and labor. I just find the middle ground. Okay, then cannot be worse off. So that means there's some complementarity. They can work together. Okay. Is this always true? Not necessarily, but because sometimes mixing thing can be worse off, right? But that is what we assume. This is standard thing. It's just same as marginal utility, but this is called the marginal product, right? Just like increase in one input, how much output you can produce more. So that is it. I don't want to go into detail. Okay, and this is the assumption usually we make. Is what we call diminishing marginal product. Okay, it's just like the marginal product is diminishing if you increase. Okay, and the reason why you want to have this negative as assumption in general is because if it's not the case, then you keep employing the same input, right? Because if this input has a fixed input cost, and if you don't have this diminishing product, marginal product, that means that you will keep employing it, right? It's because this is always positive, right? Under the assumption we have still increasing. If we still have positive in this one, then we would basically employ this unit of input, and other unit is not important, right? So that's why we always do this, right? If say this is positive, in that case we just use capital, right? Very likely, right? That's why we see a lot of people using machine, right? And so that is the idea. The question. So some definition here. I'm not going to detail, but average product is the production over the how much unit you input. Okay, you don't have this assumption idea when you talk about utility. You don't have average utility here. I mean, there's no meaning, right? But you have meaning for average product. Okay, and this is you learned before. This is isoquant, the same as the utility indifference curve or indifference set. It's just the set of input that lead to certain level of output. Okay, so because of we assume it is strictly increasing production function, the isoquant is a line. It's not a fixed set. Okay, because the assumption of strictly increasing. Okay, you don't have same as the idea of monotone preference. The isoquant is always a line. It cannot be a fixed line. Is that clear? There's no fixed line because of the strictly increasing assumption. Okay. So this is the graph, right? X1, X2. You go up, the better, because we assume strictly increasing. Okay. This is important. This is same as what we learned in the consumer theory. This is a marginal rate of technical substitution before a substitution, just technical substitution. Okay. It just if you give up 1 unit of I, okay, how many unit of J you need to maintain the same output, right? Because you give up 1 unit of I, that actually give up this much unit of production, that you need this much unit of production, the unit of J to compensate for that. So let me repeat. The numerator, right, is the output you need to produce in order to compensate the loss of 1 unit of I, right? Because each I produce this much, right? So you reduce 1 unit of I, then you need to get back this, okay? And how many J you need to employ is look at how much 1 J can produce, so just divide by that. Okay, so that is the definition. Okay, and that's come from the calculus. This is just the slope or negative slope of the isocon. Okay, basically this is just this one. Okay, and why negative slope? Because the slope is negative and this number positive, so that's why that sometimes people define as negative of this, then anyway, that's how I think I follow the textbook. So some people define negative, I know, doesn't really matter anyway. Usually we would assume this slope is diminishing in, I think, in the B.B.A. That means that this is, the slope is like this when you have 2 goodwill. In some sense, that means that this is a concave production, right? So it's a convex production technology. Okay. And if you have a 2 goodwill, the convex isocon imply diminishing MRT S. Okay. And so I have to define things like this. That technology we call return to scale. Okay. If you double your input, you have more than double your output, then what we call increasing return to scale. When you double your input, you just double your output, then it's called constant return to scale. And when you double your input, you have less than double of your output, you're decreasing return to scale. Okay. And very clearly, actually, in most cases, we assume we have decreasing return to scale. The reason is being that if this happen, then if this increasing return to scale happen, then the idea that you have many firms is incompatible, right? Because at the end we have a price-taking firm, and usually that imply we have many firms, right? Otherwise, we're monopoly, right? So if you have this, right, you can imagine if I have increasing return to scale, then I have monopoly, right? Because the bigger the scale I have, it's more efficient, right? At the end, I have monopoly, right? Then it turned out to be, of course, inconsistent with the downward slope, the upward sloping supply, right? With monopoly, right? So that's why in the classical model, we have a decreasing return scale. I mean, even constant, I don't really, even constant have some problem. But anyway, it's okay to assume constant or decreasing, but increasing we have some issue. Okay. And probably those who know macroeconomics, probably you will notice they always assume this, right? And turn out that, I mean, they figure out that increasing return scale might be actually what happened in the macro. And that's right, explain the growth theory, right? And if you know who know the AK theory, those kind of things, then probably you know that's come from increasing return scale. And indeed, I mean, recent study actually show actually that increasing return to scale. But anyway, for those who think about the work on the platform internet, or then they know the network effect actually imply this thing would happen, right? Because end up actually better have one firm to monopolize, right? I mean, at the end of the day, just like the Google, Microsoft, Apple, I mean, those market actually feature one firm dominate the whole market, but the reason is like it's an increasing return to scale, kind of, because that is coming from the consumption externality. But anyway, we're not going to talk about those. But that is, although we are focusing on this too, but recently the macro or the IO literature consider the increasing return to scale might be more relevant, actually, at least for some market or for the macro economy. But let's so keep it what it is, because that's what happened. Okay. Here, just say very simple thing is homogeneous, right? Is if a homogeneous in degree k, just like the lambda k takes out if k degree. Okay. And obviously, if you have degree 1, right? If k is equal to 1, it's constant return scale, and k bigger than 1 is increasing return scale. K less than 1 is decreasing return scale, right? So why we care about this part? Because this is the important result. We look at the textbook, okay? And the reason this is important because we already assume continuous so increasing and f0 to 0, right? And we also assume strictly quasi-concave, which is what we have here. Combining is better than is better than the worst of the two, okay? And here what is said is if we have homogeneous of degree 0 to 1, which means that we don't have increasing return to scale, right? With constant return to scale or decreasing return to scale, and that is a concave function. Okay, so later you will see why we need to assume concave, because that will guarantee you to have a nice property when you do the maximization or minimization problem. Okay, but that is something to we want to say is we usually assume fx is a concave. Okay, when we do, right? And that tells you one thing is one way to justify this is these assumptions are pretty okay, and we just have the decrease a constant or decrease in the scale, then we're done. Okay, just by assuming we don't assume increasing in the scale, then we are happy to have concave function. So concave function is good. Okay, that's something or we have been working on. So that's a key result here. But of course, it's not if and only if. So this doesn't imply bad work, but it's a one-way train. Okay, is that okay? Is that clear? Why we are working on this? Because when you're really working on your model, okay, if you ever do it, you almost always start from here. Basically, you just start from f is defensible, f is continuous, and the second derivative of f is negative. Okay, so immediately start from here. Okay, this go all the way just telling you, okay, you can start from here. What does that mean? If you're willing to assume all this, which I think is fairly reasonable, except probably the little bit about quasi-concave, maybe, I mean, because of AI or the machine, or this one might be thing as a caveat I said, but otherwise, in most general case, this is the assumption we are making. Okay. So I'm not going to do the proof because I don't think it's important at all. But if you are interested, you can go to read them carefully. But I think the proof is rather simple. But not very useful. So I just let me skip it. I guess it's unless you want me to go over, but otherwise I just keep it there. Okay. So here I want to tell you several common examples for production function that if you want to write your model, you should go ahead with that. Just like when you do consumer theory, if you write your own model, you start with Cobb-Douglas or the Leontief minimum or perfect complement, perfect substitute. Okay. Same for production. Okay. We have something like perfect substitute that is called linear production. Okay. This is the simplest production function you can imagine. Okay. Basically, again, they call perfect substitute, right? Doesn't really matter how many input 1 or input 2 you're using. Okay. As long as the total quantity the same, then you're done. Okay, so this is very simple, and you can say this is something unrealistic, but when you look at a lot of model, look at contract theory or finance theory, they sometimes use this. Okay, you look at the production from, say, a big firm, right? Production from firm subsidiary 1 and subsidiary 2, right? They just do this directly. Or look at in contract theory, or they look at production of worker 1 and worker 2, they just add together, right? So it's something, although looks very simple, but people actually use it. And when your other parts of model is very complicated, you would want to simplify other parts. That, I mean, sometimes you do that. Okay. And here is perfect complement, and they have good names in production. They call Leontief production or fixed proportion. Okay, you need fixed amount of 1 and 2 in order to produce this, right? I think that fit us very well, right? I mean, if you have only 2 eyes, right? Give you more than 1 laptop, usually it's not productive more, right? You have 1 laptop, you're just there. But I mean, some people use phone and iPad, but I give you 1 more iPad, probably it's not going to more productive than you are, right? I mean, so that fixed proportion is a good approximation to actually many scenarios, because of the fact that, I mean, there's some limitation to production technology, right? It's not something like you just keep putting things there, can work it out. Okay. And this one, as you do the homework, you will have seen Cobb-Douglas, okay? And Cobb-Douglas is this one, and then actually Cobb-Douglas is very famous for production more than consumer, because this is coming from the name Cobb-Douglas. It's basically, this is used in the macroeconomics. People use it as a good approximation of US economy. Okay, they would actually the capital labor, right? If you look at the US economy, they try to fit capital and labor, alpha and beta, okay? And usually they would put alpha plus beta is 1, and I think alpha is 0.3, beta is 0.7. Okay, and why this is important? Because under Cobb-Douglas, actually you see also from your homework, or the example we have is where under Cobb-Douglas, you always spend the same proportion on the good, regardless of price, right? Just if you still remember, or probably not. I think we emphasize here this model, Cobb-Douglas. Here is the with one half is always the same, right? Of course, why the same? Because you will later they are one half, right? If you later actually you will do your homework, you will see this ratio, okay, depend on the exponent alpha I, right? It's related to the alphas, okay? So in this model, actually, how much the GDP go to capital related to alpha, how much GDP go to the labor related to the beta, okay? So that turned out using the US data for macro, they said the alpha and beta are the return to capital and labor pretty much consistent, fairly constant over the years. So that's why Cobb-Douglas is a good one. Okay, let me repeat the argument. Because under Cobb-Douglas, okay, the money to the labor and capital, money to the labor and capital, so from the empirical, is a constant, regardless of your wage and rental income. Then that actually implication of Cobb-Douglas, right? Look at here. Regardless of the price, okay, you will spend the same proportion for good one and good two, right? If you behave always like this, then calculus is a good approximation to your consumption, right? And very often, actually, that's how people behave, right? Because you would say spend 10% on your maybe entertainment, 30% on your rental, 50% on your food, so on and so forth, right? That is more or less people would consumption behavior is more or less like this in terms of aggregate, right? Maybe, right? This is somewhat, right? You spend that money for your phone, spend that money for that, but even though the price fluctuate, this fraction is roughly the same, okay? So that's why in macro, calculus is a very good thing, right? Because look at the return to the capital and return to labor. I mean, historically is more or less fixed. I think 66% to the labor and 30% to capital. Okay. So that is the idea why calculus is very useful. Okay. Have been using this have been the main model when you learn macro, but it still is a good one. Okay. This one very technical. I think we also mentioned this is the elasticity of substitution. Okay. That I think that is a little bit complicated. Okay. So what it is here is a derivative. Okay. And you have to inverse it. Okay. You can see it's very complicated. Okay. So it's log, it's differentiate. Okay. Log of the MRTS. Okay. Over log of R. What's R? R is the ratio of the production. Okay. So it's 1% change in the input ratio lead to what's the percentage change in the MRTS. Okay. So that is, I don't know, and has to inverse. I don't know how you think, but I can't understand. But I mean, I understand what we're saying, but I mean, what is it? It's out of my mind. But maybe you understand or not. But I really don't. But mathematically, it's easy to understand, right? But it's capturing is what we call the curvature of the isoquant. How, because the isoquants look like this, right? Under the assumption of quasi-concave like this, right? How curved is this guy? Okay. And what it said is the following, basically. So you can draw a line from here. Okay. This is how much, suppose this I, this is J. Okay. And at this slope will be xi over xj, which is R. Right? The slope of this. And the MRTS coming from here. Okay, just say if you change from this, you rotate a little bit, you go down a little bit. This is a change of the denominator. How it changed this slope, okay, and to the inverse. Okay, I don't know whether you get it, but it took me quite a long time to understand what's going on. I mean, is it important? Not very important, but I mean, but this, the calculation is also very complicated. Okay, but you may ask why we care about this particular function. It's so technical. Because of this, it's related to following one. Okay, so this is the one that we care. Okay, the reason is because of, look at almost all recent papers in trade or IO or some macro. Recently, they all use this one. Okay. Basically, this is the, here I have summation. Okay, but you can see a lot of time they have integration because they consider continuum of good. Okay, but then this is the one they have been using. Of course, when you integrate, and you integrate as well. But this is the model they use. The reason why they use this is because this way naturally extend to, as I said, n go to infinity, right? When you have continuum of good, okay, that is the easiest thing you can sometimes easier to work on. Okay, because why? Because it has what we call the name suggests constant elastic substitution. Okay, so that has a very nice behavior. Okay, and it's always this one. This proof is here, but I don't want to go to proof because it's not important. No one really care. But this one has very nice property, but I don't think we have time to go over it. And to be honest, although it's very famous, I never use it for my research. But if you read other research paper, they probably you need to know exists, and at least you will not be surprised when you see it. Okay, it's not something that difficult, but that would be something that interesting to know. Okay, is that okay? We don't have time to go over every single detail here, but just to remind you, this is so common. You use it, and as we said, this is just a general case for compared to Cobb-Douglas. Okay, so Cobb-Douglas is something have been used and is easy to use, right? But if you are willing to go one step further, okay, that's more general than Cobb-Douglas, right? Because we learned this is a general case for Cobb-Douglas, right? If you remember when you talk about consumer, we also talk about this Cobb-Douglas utility, right? If you are willing to make certain assumption, you end up with preservative Cobb-Douglas and perfect complement. Same idea here. If you're willing to make some assumption, right? Cobb-Douglas Leontief preference or linear production would be a special case. So you can imagine that why in macro or IO or some trade paper have been using this CES, because this is more general than Cobb-Douglas. And why you need to more general? Because when you run econometrics, that will be more feasible. When you have empirical IO, when you have marketing model, you have more parameter to fit, right? Otherwise, your Cobb-Douglas, you will less feasible, right? Because Cobb-Douglas, you only have each one have one thing, right? And here you have a little bit more freedom to fit your model, right? So that's why it become rather convenient. But if you read the paper, you will see, okay? If you ever try to read those papers, not something complicated. Okay, is that okay? Okay, let's have a break, and then we come back, and then we will continue. So this is the thing I mentioned, is special case, but I'm not going to prove it. You can try, but I mean, there's not much benefit to try anyway. I mean, you just use it directly anyway. Hi. So during the break, I asked some of you, then they said my progress is okay, not too fast, not too slow. So I keep at this speed. If you think I'm too slow, which I think I am, but let me know. I can faster. But if this is still too fast, let me know. I can slow down, go slower. But it's trade off, right? So I go slower, then I cover less material. But sometimes less is more. So I don't know. It really depends on. But I hope. I mean, I don't go to this function, but as I said, this is very important. Okay, because it actually appears in a lot of papers. Okay, but if you really if you're doing empirical, you're really confused, but just consider this as a general case of Cobb Douglas. That would be, I think, in your mind should be more relaxed, because sometimes you see complicated math, then you pretty much scared, because it's human nature, right? Uncertainty, you see uncertainty is kind of, you're averse of that, but just you consider this as a generalized Cobb Douglas. I think that would make your mind easier. Okay, but anyway, so I hope you're okay with the production. So production is nothing we just cover last hour, just saying that okay, we have a function that we usually assume that concave, we end up with a convex isoquant. Okay, so what's going on in probably we'll finish is what we call the cost minimization problem. Okay, the firm will take the input price as given. Okay, this comparative, right? Trying to see what kind of combination of input based on technology, okay, can minimize my production cost. Okay, let me repeat the statement. The firm is facing the input market, right? They have to come there to buy input from the world, okay, from outside, and assume the price is constant because the firm is very small. Then he owns some production technology we just described, and he tried to combine different input, okay, to produce output, and he found the most efficient way or lowest cost way. Okay, that is what we call the cost minimization problem. Okay, which is very similar. It's almost similar, same as the consumer, right? Consumer facing the price, he need to consume, and the consumption transform to some utility, right? Very similar. Okay, it's very similar. So that's why we learned from the last class that would be easy. Okay, and here I take the input price as given. Okay, and this input price as given is a good approximation, but as you can see, some recent studies show that this may not really hold, especially when we talk about firms have monopoly power in input market. Like Walmart can actually have a great monopoly power to the supplier. Like Apple, right, has a very strong power to its supplier, right? And look at very big firm, okay? They have a good price setting power, right? You can imagine that you would think, right? Say in academic market, probably some of you or most of you would actually end up to enter at the end of your PhD. Actually, is a highly market concentrated, right? The top school have so much power, okay? And also is so you focus on a particular stream, right? Even say suppose you're a finance guy, right? You would focus on a particular field, say asset pricing, and you focus on the field asset pricing. Then how many people can hire you in the world? Maybe just less than 5. If you focus on market microstructure, maybe just a few people. Or you do real estate, you focus on particular empirical thing, will only maybe just 5 people hiring you. Okay, so I mean that's at the end, right? Because we are so specialized. At the end, we just only a few people can hire us, and they have a large price setting market power. They give you a job, take it or leave it, right? There's almost no negotiation in this market. Okay, you pretty much know the price already, right? How much you're going to make in this particular school, almost except the star in the market. Basically, the price is fixed. Okay, and there's no competition between the schools, right? But anyway, that's also happened in the U.S. market, right? Talking about Starbucks these days, right? And they are monopoly of the coffee making industry, right? If you look at U.S. market, Starbucks basically 80% of the market share in the U.S. And basically they hire majority of the coffee making worker, right? So what price they offer to the worker is more like they say whatever, right? And you look at the price in the Dongguan, right? They also, no, I'm not talking about that, but I'm talking about the industry, right? The factory there. And basically now they're offering, like recent news, they talk about the hourly wage of a worker, a raw worker, unskilled worker, is like $9 per hour. Okay. And they said, if you want to do, you do, you don't do, you go. Okay. They have so much a price that price exists, like there's not taking price as given. They say, this is my price, do it or not do it. It's not in this model, I assume it's different. I would just decide how many to hire, not the price. But in the real world, right, it's not likely the firm set the price rather than set the quantity, right? But in this model, we're talking about they cannot set the price. They just decide the quantity, and the quantity just adjusts accordingly. Okay. So it's very important because I want to talk about this because these are something they make. It's important to derive the result, and this is very important for you to when you write your papers in the future, right? Because of when you look how you usually write a model is look at, or empirical is look at what classical people are making, what existing literature assumptions are doing. You try to make variation, and you are trying to see what assumption they make is not reasonable, and your data may be showing this assumption is not reasonable. You can just improve, and there's a new paper. And that is how you make progress of your research, right? Regardless of your theory or empirical, they must follow some assumption to derive certain thing, right? And you have to check whether this assumption is reasonable or not. And you try to deviate from that, then you can get a new paper if you get a new result, of course, right? Or even if you drop this assumption, you still get a new thing, or the same thing also you can publish, right? But that's why folk talk about a lot of assumption, and that is main reason why B school students need to study microeconomic theory, is because it's very mathematical structure, how assumption lead to the result. And if you change some assumption, you change some result. And that is how research is being done right these days. Okay. Now, I mean, to make our life easier, we make all the price are positive, right? That makes sense, right? There's nothing is free. This input world. Okay. We assume that happened. And I follow the notation in textbook. If you're double bigger than, is every element is bigger than. Okay, to make our life easier. So next, you just go to here. It's the same as I said. The same as the when the consumer, we have a expenditure minimization problem, right? The price times the input, right? And input to output, right? Remember, consumer is utility. Take the utility, the consumption to utility, right? So this firm is the input to output, the same thing. Okay, exactly the same thing, right? And remember, we assume our utility, right, is a strictly quasi-concave, right? So we do the same assumption on our production. So everything we learn from the consumer goes continue to hold. Okay. Let me repeat. Okay. Let me write down here. Maybe it's easier to see, to compare and contrast. So at the beginning, I said consumer is transforming your consumption bundle to utility, right? The difference between the firm is he take the input to output, right? So just see the question, right? Again, expenditure function, right? Is minimize P dot X such that U X is bigger than U, right? So that is the consumer side, right? And you can easily see this is same as this C as minimum of WX, choose X, such that f of X is bigger than Y. Okay? So you can see exactly the same structure because before U, we assume it's a strictly concave, right? So here, F is also strictly concave, monotone, right? U is monotone, everything is same. So nothing new here in terms of math. Okay, is that okay? So that's why everything goes through. I'm not going to prove anything, talk about anything, but just to list the outcome. Okay, and remember, if you have interior solution, right? So here is the input price. Okay, will be same as lambda times the marginal product. So this still probably you would not like this one because it's not very clear what's going on. Okay, but this is just standard from Lagrangian. Okay, I think I don't need to talk about Lagrangian, but I want to talk about this, right? What we have is the first one, right? This is the price ratio PI over PJ, right? And the consumer is MRS, but we have MRTS, right? The same thing, right? Because for the consumer, internal exchange rate MRS is how you exchange to keep your utility the same. Here is how you change your production, how to change your input to keep the production the same, right? And this is the price outside, right? So that is the main thing you want to derive from it. And one interesting thing is if you this Fi, this Fj, you basically swap, you have this. Okay, this new interpretation that doesn't really meaningful when you talk about consumer, but it's meaningful to talk about firm. Okay, is when have one input, okay, Fi, this is the marginal product, okay, over the wage, okay, is how much you need to increase 1 unit, right, of output for how the cost of increase 1 unit of output through increase in input I. Okay, let me repeat the statement. This is how much you need to spend if I increase 1 unit of output, sorry, through the output for the input I. Okay, put it this way. If you put 1 unit of one more unit of input I, this is how many product you produce, right? It's a cost of doing it, right? And this must be same for every input. Okay, is that clear? Is okay. So let me repeat. Okay. So if you increase, if you put in 1 more unit of okay, you spend $1. Okay. How many unit of I you can have? W1 over Wi, right? Then how much for spending $1? How much productivity you get? Is Fi. Okay, let me do it. Okay. I spend $1 on I. Okay. How many unit of I have? 1 over Wi of I. Okay. Now if I have 1 unit of I, okay, how much I produce more? Fi more, right? Marginal product. Okay, so you multiply this is I spend 1 more unit on I will get Fi over Wi more, right? So if I give you $1 more, you would be indifferent spending on any input. Is that clear? The next one is reverse way to think. Okay, it's the cost of extra output. Okay, if I need an extra output, okay, how much unit of I need? Is 1 over Fi. Okay, and what's the cost? Because 1 unit is Wi multiplied by that. Okay, it's equalize everything. Okay, so these two are the extra interpretation for the cost minimization problem, which doesn't exist when we talk about utility. It doesn't mean too much thing because utility thing. I mean, of course, you can sort of say the same thing, but it's not very natural to talk about those. You can also talk about that. It's not a big deal, but I mean, well, the extra cost of having extra utility, I mean, that's fine, but this is something extra. Interpretation has some better meaning. Okay, I mean, as I said, I mean, you can also do it on the utility, but it doesn't mean too much. Okay. So this is actually follow from the consumer, right? When we have a increasing strictly concave, right? Strictly concave, you always have a unique solution, right? Because if a two solution, then anything intermediate is better, right? So that's why it's not you always have unique, okay? And what we call the conditional input demand, okay, is the result that you put it back to this one, okay? This is same as the Hicksian demand or compensated demand, right? The same thing. Okay. So I'm not going to, I think, do we have to talk about property? I don't think we do, right? No, we do, but just to give the idea here, right? This is isoquant, right? This is the price ratio, right? And what it's talking about is we are moving this line. Okay, so let me repeat this statement. The cost management problem is we have the production target Y here. Okay, this isoquant means everything here or upward can satisfy this constraint. Okay, and because of we have increasing production function, okay, it must be the optimal solution must be in this line, never be here, because everything here will be suboptimal because you produce more than you need, right? You just produce exactly what you want. Okay, and the optimization problem is just to try to figure out how much total expenditure, right? How the slope is given by the price ratio, W over W2. So you just, this is fixed, you just move up and down. Okay, and you can see optimal because it will be here because of the Cauchy concavity. So cause I'm going to give you this one, must be one solution here, right? Is that clear what's going on here? The same as the utility, and you move the budget line. Okay, just a little bit careful is this ratio, right? Just like this. Okay, is that okay? Is that okay with this one? Okay, you may have learned it in the intermediate, but probably forget. But and okay, this is one thing we just want to mention, but this is natural. Is homogeneous degree 0 in W. Okay, that means that if you double your input price, okay, the thing is the same. Okay, because look at the graph again. Okay, only matter for the solution is just the ratio, right? If everything double, the slope will be the same. Okay, this is nothing with the price, right? And only with the price is this guy. Okay? Of course, if you change the price ratio, then change, but otherwise, the same thing happens. Okay. So I guess it's not complicated. Okay. And here we have something I mentioned because the book mentioned, but I don't think it's any important thing. This is called normal input or inferior input, same as normal good and inferior good. Okay. Normal good, inferior good is saying that if I oh, sorry, this will be y. Sorry, the typo. Yeah, this is y. And what is said is, in the consumer, right? It's like if I change my income, how my demand changes. Same here, right? If I change my output, okay, total output, what does it look like? So it look like, do I have a graph here? No, just like, now this is the, maybe I draw it here. It's very simple. So I have isoquant here, right? And I have a, sorry, this is the production plan, right? Now I increase my production up to here, okay? And I would have other line, right? At the point here, right? If it goes, the input increase with my input, that is called normal input, okay? If it turns out the line is like here, then it's a inferior input, okay? So we just say when the Q keep goes on, whether you would do more input or do less input, okay? And if increase, then it's normal, otherwise it's inferior, okay? And I do it because books define it. I just want to keep it there, not very important, okay? And the expansion path is like, you just, usually you would something like, this may come out, okay? It's normal, right? But it's possible that you can go in this direction. Okay. Sometimes raw labor is inferior input, right? Increase usually at the low production level, you increase production, you hire more, but at some point actually will be backward bending because you will use machine, right? So, but anyway, it's not something terribly important. Only if you care about macro, but otherwise, usually don't worry because you always usually what you have in general function we have is also usually is a normal. When I look at this calculus, right? Actually, you can see it's normal. Okay, in generic cases, right? So this is the Lagrangian. You're going to derive this. At the end, you're the same thing, right? The marginal product, same as this guy, right? And if you alpha 1 and alpha 2 in that particular case, right? Same as the one we have is W1, W2 times X2 is same as W1 times X1, right? So if alpha are the same, right? So the expenditure on the good will be the same, right? So you will end up seeing something like this, okay? Something complicated, but this is the standard thing we have here. Okay, I mean, looks terrible, but shouldn't be difficult for you. And just to remind you that, I mean, when I have this kind of example, okay, this is the minimum requirement for this class. In order to get a pass for this class, I mean, you should know all the example I have read, okay? if you but anyway, you do the homework like this. So homework is similar to what you see, but it's the minimum requirement for this class. Okay. Hopefully you okay with this one. Okay. And this is what we have, same as the expenditure function. Okay, with the cost function. Okay, and you put it back the cost minimization, the conditional input demand back to here. The result is actually the cost minimization. Okay, so this one you can see the only thing is the main assumption we put here is the firm consider input market is a price taker. If the price exogenous, then this will be fine. Okay, and in most cases this is a good assumption. Okay, because input price is going to be demanded by a lot of industry, right? The labor will be required by many industries, same as input. Okay, so unless you are talking about very specialized market, in general, this assumption we make to arrive this is very minimal. Okay, because the firm will face two markets, right? Input market and output market. Okay, here we just assume things the input market perspective. Okay, the how to combine is input to produce output. Okay, is that clear? And this is just saying that how the conditional input demand with the total cost function, and just put that in. But I think this is trivial, right? Because we have a unique outcome, then that's fine. Okay, there's nothing deep in this context. Is that a question? If no, we just will quickly skim over everything here, but I think kind of trivial. When output is 0, that is 0. I think that is trivial, right? Continuous in price and output, I think is also, we have been, it's not easy to prove it, but I think should not be a big difficulties to think, right? And if input price are 0, then your total cost will be increasing. Why? You produce more, your cost goes up, right? And if your input price goes up, then your total cost will not be go down, right? And if your input price double, right, your total cost will double. Okay. Only thing that is less trivial is why is concave input price. Okay. And why the surplus llama. This is exactly we just explained at the very beginning of the class. Why is it the expenditure is concave? This is exactly follow the graph we actually talked about this at the beginning of our course. Same idea here, right? You can change the price, but you keep the same bundle, it will be linear. Optimal will be lower. Okay, so same would apply in this context, right? If you can draw the same graph, right? You can input price changes, you can keep the same production, it will be linear, but optimal will be lower. So that's why it's concave. Okay, but we are not going to prove it. But you can check the book for a proof, but yeah, don't prove it. So we have again the surplus llama. This is same as what you learn in the consumer, right? I think consumer we have the same, right? You differentiate the expenditure, you get the commensurate demand. So when I differentiate the cost function, then I get the conditional input demand. Okay, so there's nothing new here because exactly the same thing, right? I mean, the only thing different is before is you transform your consumption plan to utility. Now I transform input to output. Okay, because the thing there's no difference because we assume only the firm is a single, only one output, right? When you have more than one output, then this thing will be a little bit different, right? Not just one inequality, but a set of inequalities, then the thing will be very different, right? When focus on single output thing, then everything can just go without any complication. Is that okay? Any question? Well, I think everything is very trivial, right? I mean, except this guy needs some thinking, but this is just M.Phil theorem, right? Is that okay? Now, if you put it back, then you get this guy. Okay. So we're likely that you will do something similar for your assignment too, if I ever give you later. Okay. Generalize this to n, then how to do it. Okay. So only work on two. Good work is intermediate thing. Okay. Ph.D. class, you have to do n good. Okay. So that is something at least to there's some changes. Okay. So I don't know how useful is for the rest of this is, but historically people study this a lot, and also you do that in your principal class as well, is a lot of cost function, average cost function, marginal cost function, all this crazy thing goes on. Honestly, I never use it. I mean, for my research, I mean, I do have a cost function, of course, but I don't utilize any property here. I mean, I don't use the MC, the short run, long run, all the thing, but it's important historically. And I'm just going to be brief here. Just mention something in case you read the book. Because I try to make sure I cover the thing in the book. But I just being quick here. So why they care about this is because of the fact that when we do so many things at the end, right? We end up with a cost function. Okay. So why we care about this is because at the end of the day, when we consider writing a model, we immediately start with the firm cost function without talking about production technology. Right? When you try to write a model, we just start, okay, this is the production function, this is the cost, okay? And you have to know how it comes in. Right here, just telling you that, okay, it comes from production technology. Okay, same as the idea when we talk about preference and utility. Okay, why I talk about utility, or assume consumer maximize utility. Okay, it comes from preference. Okay, here what I'm trying to say is when I talk about firm, how they compete, how to make things, we start just directly with the cost function without doing anything, right? Then just trying to give you the idea, okay, the cost function coming from some technology in the background. We make some assumption on technology, and if we continue to assume the firm is facing a input price market that is competitive, that will cost function. Okay, but do note that there is some assumption behind. Okay, it's different from preference and utility, where the two things are closely related directly. Okay, because utility is just a representation of the preference. You make some assumption, but the cost function is not directly come from technology. You need to make assumption of how they behave in input market. Okay, as long as the input market is perfectly competitive, then everything goes. Okay, if not, then things are different. Okay, I have to just to emphasize this point, because when you work on the model, we just go directly to the cost function. That's it, right? You don't go further. Okay, but just to make sure that you understand what's going on here, you must know there's some gap between technology and cost function. Is how firm interact with the input market. Okay, so here we take cost function as given. Okay, so we try to see some analysis here, long run and short run, and how they look like. I don't think they're terribly important because they're only important for historical reason. People start to understand what's going on in general equilibrium, how the firm shut down and open. I mean, there's something there, but in terms of math and technology and math technique, it's not complicated. So everything is from here on is for the cost function is nothing more than what you learn from the intermediate. Okay, just some little bit more technical details, but nothing deep here. So just define average cost is the cost over the y is AC. You differentiate is the MC. So I don't think I need to talk more, but that is something you learn in the intermediate. Okay. So here I think this philosophical question, okay, is important. Okay, what is long run and short run? Okay, and this is artificial way to think about things. Okay, just the definition is when you have long run, it means that everything you can change. There's no restriction. And short run, there's something you can't change. Okay, and when you learn intermediate or principle, they will say, okay, when you sign a contract, okay, if you sign a contract, then say you sign a contract to rent that place, or you sign a contract to hire somebody. Okay, once you sign the contract, then things become fixed. Then you can just change that you can't change, right? So basically, you can imagine some kind of contract is a way to distinguish the two. Okay, or you think about things day-to-day business is short run, right? When we talk about long-term planning, there's a long run. Okay, it's artificial. Okay, so do know this artificial. It's just like we're talking about this short run is kind of restricted problem. Okay, and this is a full problem. Okay, and when it's full problem, when you call about restrict problem, it depends on whether you want to change those things, right? Because you talk about I sign a contract, whether I want to touch a contract, or I don't want to, or I can talk about after the contract is over, right? So that is the main difference. Okay. So there's nothing deep here, okay, in terms of math, in saying that something is fixed, okay, means that you have some factor x bar that cannot be changed. Okay, in that case, the minimization problem will be the same, except that you're not going to change this one, right? So that is nothing new here, right? Nothing new, except that I mean there's some mathematically there's something that you can't change, right? So, but I think we make a great deal when we do undergrad principal class. We talk a lot about this, but there's nothing but something that is a restricted problem. We're just holding this a constant, and everything continues. Okay, just reduce the problem. Okay, and that leads you to a short run total cost thing, right? And there will be short run average cost or marginal cost. Okay, and I think that is not very important. So for this property, I just say it. Probably you have learned it already. Okay, so how they're related, right? If the long run cost, you have the fixable price, okay, fixed price, right? So the price for the fixed factor, price for variable factor, this is output, okay, and this is like the short run, okay. This is short run based on the price of the variable factor, price of fixed factor. This is your output. Okay, this is your input demand under this output. Okay, this is optimal input when you produce Y. Okay, in that case the same. Okay, and the next is something like this math. I'm not going to show you the math, but actually you can prove it easily. But just this graph. The AC, if look like this, the MC will pass through in the middle point. Okay. You may ask why. Probably it's worth to prove it because it's very simple. So this AC, right, is C over Y, right? Use the you differentiate y, the product rule, y square, y differentiate c is MC, right? Is minus c, okay? And in that case, right, AC is positive if and only if this guy positive, right? And you divide y on the other side with MC bigger than AC, okay? So that's how you prove it. But I think you learned it in your undergraduate. Is that okay? I think the proof is rather simple. And you also learn something like this: is the short run AC curve is tangent to the AC. Do I have the graph here? I don't. But this is something you learn. But you can prove it, but I'm not going to prove it. But I can just draw it. I mean, there's no point to do the math here. But I just, if this is the Y, and this is AC, and this is somewhat the short run AC. Okay. So I think you've seen that in your, undergraduate textbook. But how do you prove this particular? But I think we never prove it, right? And this slope is the same, right? Because if the reason is if you move from here to here, that means that you change some fixed factor, right? And it must be the case is envelope in that position, right? Because this is the most flexible one, right? So the cost must be below the short run one must be above the long run one, right? And at the optimal point, right, it must be tangent, right? It must, because even though short run is not so good, but at that particular point, it must be achieved the same rate. Okay, but anyway, I'm not going to go to the detail to prove this because there's no point to worry about that. Okay. So since I don't have time, maybe I just go to this expression because I think even though I don't cover it, you want to know a little bit. Okay. How do we prove this particular thing? Why it is the case? Okay. So the thing is like this. Okay. If you take this short run, so it's a long run cost curve. Okay. And when you differentiate with respect to y, it's like this one. Okay. It consists of two terms because of the differentiation idea, because you would affect, okay, how this argument y, okay, but also affect this how you produce a fixed factor, how you change your fixed factor. Okay, just to remind you why of this function again. This is the minimum cost function given the price of variable factor, fixed factor, and production level. Okay, this is short run cost. Okay, at this particular output, right? And optimal in the sense that you keep changing the fixed factor. Okay, accordingly. So that's even though it's short run, but you adjust your fixed factor such that it's optimal. So that's why they're the same. Okay, so the first thing like this, and that's why if you change y, okay, you will change your non-fixed factor, right, variable factor, but you should also change your fixed factor accordingly. Okay, so that's why when you look at this expression, okay, when you differentiate, the first item is how it change your short run cost without any change in fixed factor. Okay, and you will have the same for fixed factor, but you have to differentiate for each fixed factor, right? And the factor in the short run that's optimal, okay, this is 0. Okay, so what you left, That's why they are tangential to each other. Okay, so that is the proof for that. But I can see some of you may confuse or not, but doesn't really matter because I don't think I ever use it in my life, except I teach the class. But probably it's the third time I do this. The last time I did it in the graduate school, and the second to last time is last year I talked about this, and this is the first time I talk about this. And I do think that probably most of you would never use it for your life, so that's okay. But there's nothing but just this graph. Okay, and the idea is being that you increase your production, the cost will increase this much. Will be same as the short run because you are moving a little bit. This is tangent, right? So you just move a little bit. So that's why it's no change, because there's only small changes, right? Because at the optimal point is already the fixed factor is at optimal level, right? So slightly change in the production level wouldn't make your fixed cost, fixed factor bad. Okay, so that's why you have this function there. Is that okay? I mean, slightly a little bit more difficult, I would say, because not very useful, but somewhat technical. Okay, so let me end here today, and then after that we'll finish the maximization, and then we'll slightly be behind the schedule, but it's okay. I think it's better to have a stronger grasp than a rush. Okay, I will see you next week. Make sure that next week is the not deadline, but October the 2nd is the deadline for the homework. So you can take a picture or whatever, just as long as it's readable is fine. You don't need to type it out. Okay, you just write it also fine. Okay, I see you. Somebody blackboard. Okay, thank you.